The first two problems that we'll look at involve going from the decimal form to words, and then we'll go from words to the decimal form. Okay, so to start out here, we're going to look at number 2, and we'll first represent whatever's in front of the decimal. That won't be too awful much work. We've got 8. All right, that was pleasant enough. The next thing you'll do is attend to the fact that there is a decimal here. You always represent a decimal with the word "and". All right. The next step will be to attend to basically the number behind the decimal, and initially I'm going to ignore the fact that it is a decimal. This is 286, so that's what I'm going to write, 8 and 286. Some people say you hyphen up through the 20s. I've seen 86 hyphenated. I'll make it hyphenated. That sounds fun. So 8 and 286, but we still have to identify basically the place value of this decimal. Okay? So right under the decimal, that's sort of thought of as the ones place. But that once you get to your first decimal place, that's the tenths, then the hundredths, then the thousandths, then the 10,000ths, then the 100,000ths. Okay? So what we have here is 8 and 286, and this is 100,000ths. So 86, I'll come back under here to write that. Hundred thousandths. All right, so these are the words that describe this decimal. 8 and 286 hundred thousandths. Okay, we'll take a look at number 4 and do things a little bit in reverse, but the number in front of the decimal, that's pretty straightforward, so we'll just do that. 6 and, that's going to be 6. Oh, that's right, I'm supposed to be writing the number. Well, that'll be a lot less work. Scratch that idea. In fact, let's just get this off our screen. There we go. So 6, we have our 6. Hopefully you recall that and, that refers to the decimal. 516 10,000ths. If I write 516 right behind this decimal, I might not end up in the right place value. So I'm going to take a closer look at my 10,000ths. Okay, I'm supposed to get to the 10,000ths place. So I would have, where to put my 10,000ths? I'll put it right here. So that would be a 1, 0, 0, 0, and one more 0. So see how I've written the number 10,000 and my 1 is underneath the decimal place? So when I write 516, I want to be sure that the 6 ends up right here. So I'll need one more 0 to hold that spot. So this is 6 and 516 10,000ths. Okay? And we'll take a look at number 6. Slide this up here. Okay, they want us to insert an inequality sign between the two numbers. And looking at number 6, in order to indicate how this will work with negative values, perhaps I'll do it first with positive values, because that's easier to understand. So I'm going to write 76 hundredths and 75 hundredths. And when you're trying to indicate which is greater, you proceed digit by digit. All right. The 7s are the same, the 6 and the 5 are different. So all I really have to compare is the 6 and the 5. And obviously 6 is greater than 5. But if both decimals are negative, your inequality sign is going to be exactly the opposite. Okay? And this might be, a lot of times you'll say, well, the one that's greater is closer to 0 if you're talking about negatives. Perhaps it would be a little easier to see if I just give you, let's compare 3 to 5. Obviously you would say 5 is greater than 3. But if I gave you a negative 3 and a negative 5, negative 3 is greater than negative 5. And you might think of it in terms of, I would rather be $3 in the hole than $5 in the hole. There's different ways to think of it. But again, I usually just consider it with all values positive and then reverse my sign, my inequality sign. We'll take a look at number 8, and this just underscores that you proceed digit by digit. Right after the decimal, I have a 2 and a 0. That's all I have to look at. Nothing else matters but the 2 and the 0. And quite obviously, 2 is greater than 0. Okay. The next one we will look at is number 11. So let's get that onto our screen here. There it is. All right, they want us to round this to the nearest tenth. Okay. Let me straighten this up just a little bit. All right, to round this to the nearest tenth, first you identify the tenths place, which is right here, and then you look at the next digit. If it's 4 or less, you round down. If it's 5 or greater, you round up. So this would be 8.0. All right, we just rounded it to the nearest tenth. I'll take just a second to speak to the logic of that. Give myself a little bit of blank. If it's 0 through 4, so if I had, I'll need more room for this. All right, if I had 8.04, 8.03, 8.02, 8.01, or 8.00, and I was rounding to the tenths place, I would round down, and I would get 8.0. All right. If I had 8.05, 8.06, 8.07, 8.08, I'm going to have to zoom out just one here, or 8.09, I would round up for any of these, if I was rounding to the tenths place, to 8.1. All right, so this is our dividing line right here. 4 or less, you round down. 5 or greater, you round up. And if you get stuck in the middle of a test, in the heat of battle, you forget, where's the dividing line? Refer back to the logic here. How many numbers do we have beneath the dividing line? We have 1, 2, 3, 4, 5 numbers beneath, and we have 1, 2, 3, 4, 5 numbers above, so we split it up evenly. The thing that makes the dividing line a 4 is you start with 0, 1, 2, 3, or 4. All right. These you round down. These you round up. All right. And let's see. We'll also take a look at number 14. Bring that into view and zoom in a little. And what is it they want us to do here? Write the decimal as a fraction or mixed number in lowest terms. Okay. For number 14, this is 39 and what's the decimal value here? That's 89 hundredths. All right. So we have 39 and 89 100ths, and this will not reduce, so your answer actually just ends up looking like that. Okay. If I had 39 and 8, let's say 85 hundredths, if I had 85 hundredths sitting here, I would be able to reduce that, right? Because 5 would go into 85 and 5 would go into 100. But in this case, 89 is a prime number, so we can't reduce this at all. All right, we'll take a look at number 15. Write the fraction as a decimal, and let's see. If necessary, use repeating decimal notation. That word's off the screen, notation. Okay. Anytime you want to change a fraction to a decimal, you simply do what this tells you to do. This is 1 divided by 5. All right. Here's 1 divided by 5. Notice it doesn't fit. All right. As soon as that occurs, you put in your decimal point, tell the world, load up on zeros all day long if you feel like it. You probably don't need that many. I'm just trying to make the point here. And then you proceed with your division. 5 goes into 10 twice. So we have our decimal, 2/10. Okay. There's other ways to get there, but this way always works. So I'll leave it at that. Maybe we'll use the other method for number 17 here. Well, I guess I'll do 17 both ways. First, I'll go in this manner to show it always works, and then I'll show you a shortcut you might want to use. All right. We're still trying to go from fraction to decimal. So I indicated that this system always works. So this is 43 divided by 20. So we'll need some room here. Here's our 43 divided by 20. Well, it starts out nicely enough. 20 goes into 43. Let's see here. 20 goes into 43 twice. Okay. 2 times 20 is 40. When we subtract, we've got 3 left over, and 20 won't fit into 3. All right. So we need a way to keep going. They want this written as a decimal. So what we'll do here is 43, it's understood that there is a decimal sitting right here. We just don't bother to write it unless we have to, and now we have to. Because if I put a decimal here, I can load up on zeros all day long. Notice I haven't changed the value of 43. All right. But if I put in a decimal, or if there is a decimal underneath, you have to tell the world. Okay? And now I'm free to just bring down zeros and continue on my way. So we bring down our 0. 20 goes into 30 once. And when we subtract, we have 10 left over. Let me just zoom out one here. Bring down your next digit. 20 goes into 100 5 times. And I could subtract, but you don't really have to bother because nothing's left over. Okay? So 43 over 20 can be written as a decimal 2 15 hundredths. And I'll show you, there's actually another way to get there. Well, the other way looks kind of long all of a sudden. If this denominator is some factor of 10, then I can just read it as a decimal. But once I get there, I would have to do a lot of reducing. I'll just show you real quick. If I multiplied by 5 and by 5, I would get something hundredths. But 5 times 43 is 215. Or is it bigger? No, that's right. But notice this is still written in fraction form. So if I have 215 divided by 100, I'm just going to have to back out and do that. Maybe I'll do it right here, just to show you there is another way you can get there. I think this will be the last one we do on this video. Alright, so I claim that if I divide I'm going to have to zoom out a little more. If I divide 215 divided by 100, here we go. It goes in just fine to start, right? 100 goes into 215 2 times. That gives me 200. I'm sailing along. Everything's nice. I've run out of digits. So, I use the same trick I did up here. When I run out of digits, I put in the decimal. It's been sitting there patiently all along. I tell the world, and I can load up on zeros. All right. Then I continue on my way. Bring down a 0. 100 goes into 150 one time. Oops, better make that a 0. 1 times 100 is 100. And then we're left with 50. I'm moving on. I'm going to zoom out again. This is about to clean up. I just want everything to fit on here, though. There we go. All right, so I've got my 50, right? I just did my subtraction. Bring down the next digit. 100 goes into 500 5 times, and obviously nothing left over. So notice you get to the same place. All right. Sometimes it's actually a little easier to proceed like that. In this case, it was probably a little more work.